In this short video, we're going to look at some further interpretations of how we can understand the mutual information. So the next interpretation I want to give you is a statistical view of what mutual information is. We can think about getting a zero result for mutual information between x and y as being an equivalent statement to saying that x is independent of y, or equivalently, that y is independent of x. In this way, we can actually view the mutual information as a non-linear form of correlation. We'll see further relationships between mutual information and correlation later on in this course. The next interpretation I want us to look at is to think about self-information and uncertainty. This is a reason why often we accidentally or otherwise conflate the terms information and entropy. So here on the diagram at the moment, we're coming back to a Venn diagram view where we're just looking at the uncertainty about our variable x. We can think about self-information. How much information do we get about the variable x from the variable x? If we plug this into the mathematics that we've already formed for the mutual information, we get the sum of two entropies minus the joint entropy of x and x, which is simply the entropy of x itself. So that term cancels with one of these and we're just left with the entropy of x. So we see then the entropy that x provides about itself is equal to the total uncertainty in x. And that makes sense, right? Because we learn full information from x about itself. The uncertainty reduction that we get from x is equal to the full uncertainty that we had about x in the first place. And that's what's shown in the diagram there. So here then we see that the entropy about x, the uncertainty, is equivalent to the self-information, the uncertainty reduction, that is obtained from that variable about itself. So in this way, we see that entropy and information are complementary quantities, and that, as I say, is why we often use the terms entropy and information interchangeably, even though strictly speaking, we probably shouldn't do that. Okay? The next interpretation I want to give you regards Kelly gambling. This is a very old interpretation of information theory, and a very interesting one at that. So here we're going to consider a situation where we are gambling on the outcome of a variable x. So we're gambling on outcomes little x. And here we're gambling with a bookmaker who's paying fair odds, who's giving a payout that's equal to the inverse of the probability, the real probability, for each winner x. So if outcome little x has a 50% chance of winning, the payout for that will be 2-to-1 odds. Okay? We're also considering that we're going to invest all of our capital on each race, and we're going to do this over repeated races. Now, for the repeated races is important. If it was a single race, then what we do might be very different. We might bet all our money on the favourite to sort of have a decent chance of retaining something, or we might go for an outside horse to have a chance at having a very big win. But if we're having repeated races, then our strategy is to survive in the long term. We can't just bet on one horse if we want to survive in the long term, because if that horse doesn't win, we lose everything. Okay, so we want to be able to survive, and the best strategy, it turns out, is to spread our investments over all the horses so that whoever wins, we still survive, and we can play on the next race again. But we want to spread our investments as per the true probability of those horses winning. So for the horse that's going to win 50% of the time, we put 50% of our capital on that horse, and so on. That turns out to be the best strategy in the long term. And in fact, the best strategy is actually a neutral strategy. Whichever horse wins, we get our full investment back at the end of the day. Doesn't sound, well, obviously we're not winning anything net overall, but it is actually the best strategy. Any other strategy will result in you losing money. However, if you have some side information here, let's call that y. If you have some side information that changes the way you view the probabilities, it changes your expectation of x winning from the prior probability here to some posterior probability given y, then your best strategy is actually to spread your investments as specified by that posterior probability of X given Y. Okay? When you do that, it turns out that the average growth rate of the investment return that you will get when you invest in that way, with respect to gambling as per P of X, is the mutual information between X and Y, which I think is a very interesting result.